What is tungsten? Hello, Detailed Engineering. I'm Gustavo Pereira, and at the request of one of our subscribers who left a comment on a video about copper, today we're going to talk about a very powerful metal, tungsten. Tungsten is a metallic element with the symbol W and atomic number 74 on the periodic table. It is a hard, dense, and strong metal often used in applications that require high temperatures and high resistance. Some common uses of tungsten include filaments in incandescent light bulbs, high-speed cutting tools, and in the construction of aircraft and missiles. It has the highest melting point of all metals and is also an excellent conductor of electricity. But when was tungsten discovered? Tungsten was discovered by two Spanish chemists, Fausto L. Rullar and his brother Juan José L. Rullar, in 1787. They discovered the element while analyzing a mineral sample from the Huaytapallana mountain in Peru. The mineral they found was called wolframite, and it was from this mineral that the element tungsten was first isolated. And it's because of the name wolframite that tungsten has the letter W on the periodic table. Tungsten has a very high melting point, 3,422 degrees Celsius, which is the highest of all metals. For comparison, for example, iron has a melting point of 1,538 degrees Celsius, aluminum is about 660 degrees Celsius, and copper is about 1,084 degrees Celsius. Tungsten is also very hard and has a high density, making it ideal for use in high-strength and high-temperature applications. It's harder than steel, titanium, and other common metals. It also has high electrical conductivity and a low coefficient of thermal expansion, which makes it useful in electrical and electronic applications. In addition, it has great resistance to corrosion, making it useful in applications where this characteristic is important. But there's a catch. Tungsten is very brittle and difficult to work with in its pure form, but it can be alloyed with other metals to improve its ductility and workability. Once alloyed with other metals, tungsten alloys are used in applications such as the aerospace sector, defense systems, electrical and electronic systems, and even the medical sector. It can even be used as a refractory metal, which means it can withstand high temperatures under extreme conditions. Tungsten is a relatively rare metal and is generally more expensive than other common metals such as steel, aluminum, and copper. But where is this element found? Tungsten can be found in nature in the form of several minerals, such as wolframite, scheelite, and ferberite. These minerals are usually found in association with granite and other igneous rocks, but they are also found in small amounts in many other types of rocks. Tungsten deposits are found all over the world, with some of the largest reserves located in China, Russia, and Canada. Other countries with significant tungsten reserves include the United States, Vietnam, Brazil, and Portugal. We can find tungsten even in association with other metals such as gold, silver, and copper. And the process of obtaining the element tungsten from its minerals, of extracting this element from minerals, usually involves several steps. The first of these is, without a doubt, mining, which can involve open pit or underground mining methods. After the ore is collected, it goes through a crushing and grinding process, where it is ground into a fine powder to release the tungsten minerals. After that, this fine powder goes through a concentration process. The fine powder is processed to separate the tungsten minerals from the other minerals. This is usually done using gravity separation methods, such as shaking tables or magnetic separation processes. After being concentrated, it moves on to the roasting stage. The concentrated tungsten minerals are then roasted, and this is a process that removes any impurities and prepares the minerals for the next step, which is leaching. In this process, roasted minerals are leached with fluids like sulfuric acid or sodium hydroxide to dissolve tungsten. Once we have the tungsten dissolved in the fluid, it is treated with a reducing agent to precipitate the tungsten as a solid in a process we call precipitation. It's like using those pool chemicals to settle impurities to the bottom, except in this case, we use a reducing agent to settle the tungsten. After removing the solid tungsten from the precipitation process, the material might still have some impurities, so it goes through filtration processes to remove any remaining impurities. After filtration, the precipitated material is then calcined, where the process removes moisture from the material and prepares it for the next step, which is reduction. The reduction process transforms the calcined tungsten and reduces it to metallic tungsten, using a reducing agent such as hydrogen, for example. And finally, we have the refining process, where the metallic tungsten is then refined and goes through a new phase of removing any remaining impurities. And the final product is high purity tungsten. It's worth understanding that this whole process can vary depending on the specific mineral being processed and the purity and form of the final product. Where can tungsten be used in engineering? Tungsten has many uses in engineering due to its high melting point, high density, and high strength, and mainly because it can be combined with other metals and materials to form alloys and compounds. It is usually alloyed with other metals, such as cobalt, nickel, and iron, to produce tungsten carbide, which is extremely hard and has a high melting point. This tungsten carbide is widely used in cutting tools, wear-resistant parts, and other high-performance applications. In addition, tungsten can also be combined with other materials to form composites. For example, tungsten particles can be added to plastics to make them electrically conductive and to increase their strength and durability. You can also combine tungsten with ceramics, to make high-strength materials that are resistant to high temperatures, which is widely used in the steel industry, such as in furnace refractories. Tungsten can also be combined with materials like titanium, tantalum, or molybdenum to make high-performance alloys used in aeronautical, aerospace, and even defense and security systems. We can even use tungsten in nuclear engineering, using the material as radiation shields, and even in the control wings of nuclear reactors. It is a very important and necessary material, especially in engineering, and its characteristics are unique within our periodic table. Did you already know about tungsten and its uses? Have you ever thought that those drill bits might contain tungsten? Or have you already replaced that incandescent bulb with an LED one? Leave it here in the comments, I want to know. I'm going to leave 2 videos here on the side that you might like as well. So click on one of them to check it out. Help us by leaving your like on the video, subscribing to the channel if you haven't already, and sharing this video on your social networks. That's it, engineering lovers, a big hug, and I'll see you in the next video.